Just like integers, rational numbers, and irrational numbers are different kinds of numbers, an imaginary number is just another kind of number. The symbol for an imaginary number is an italics I. And the imaginary number has one unique property. When you square the imaginary number, you get a negative number. When you square I, you get -1. I is the only kind of number that squared gives you a negative number. Any other number that we square will always give us a positive answer. What does that do for us? Well, if I take both sides of the equal sign and I take the square root of both sides, the square root of I squared is just I, and the square root of -1 is the square root of -1. So the imaginary number I has a value of the square root of -1. If I square I get -1. Let's use I to solve for x. In this example, we have a quadratic equation because x is being squared, but we only see x written once in this problem. Since we only see x written once, we're going to solve for x directly. We're going to undo the order of operations. We have x plus 3, we have x squared, and we have -1/8 times x. To undo these in the correct order, I'm going to first get rid of this -1/8. Now I could divide both sides by -1/8, but instead I'm going to multiply both sides by the reciprocal of -1/8. The reciprocal of -1/8 is -8. Since these two are inverses of each other, they're going to undo each other, and I'm left with just x plus 3 squared equals -56. Now I need to get rid of this squared before I can get rid of this plus 3. To get rid of this squared, I'm going to take the square root of both sides of my equal sign. And since I added in the square root, I have to remember my plus or minus. Square root and squaring are inverse operations, so I'm left with just x plus 3 equals plus or minus the square root of -56. At this point, I need to simplify this irrational number. X plus 3 equals plus or minus. Now I'm going to rewrite -56 as a series of numbers. The largest perfect square that divides 56 is 4. And 56 is 4 times 14. Now I need to compensate for the fact that this is a -56 by multiplying by -1. So really what I did is rewrite -56 as 4 times 14 times -1. The reason I do that is so that I can distribute that square root to each number. Square root of 4 is 2. The square root of 14 is the square root of 14. And the square root of -1 is I. So I simplified the square root of -56 into 2 square roots of 14, I. Notice that I can take the square root of this negative number, as long as I include I. I allows this problem to be solvable. Without I can't take the square root of a negative number. Last step to solve for x, subtract 3. Now I'm going to rewrite my answer with the -3 out front plus 2 square roots of 14i or x equals negative 3 minus 2 square roots of 14i. Now I can't simplify anything here because negative 3 is just an integer, and this 2 has the square root of 14 and the I attached to it. So this is my answer in simplified form. Let's look at some operations that involve imaginary numbers. To subtract or add imaginary numbers, I need to add or subtract my like terms. If I look, 2 is an integer, 9i is an imaginary number. 9 is an integer, 6i is an imaginary number. So I need to combine 2 and 9. So I have 2 minus 9. 2 minus 9 is negative 7. And now I need to combine 9i and 6i. But I have a negative 9i minus negative 6i. This negative sign needs to be distributed to both things in the parentheses. I need to subtract everything. So I have negative 9i minus negative 6i. So I really have negative 9i plus 6i. A negative negative becomes a plus. Negative 9i plus 6i gives me negative 3i. Let's look at multiplying imaginary numbers. 2 minus 9i, 9 minus 6i. And I'm multiplying in between these two imaginary numbers. Well, in order to multiply, I need to make sure that I distribute. So I'm going to take 2 times 9, which is 18, times 2 times negative 6i, which is negative 12i. Negative 9i times 9 gives me negative 81i. And a negative 9i times a negative 6i gives me, well, a negative times a negative is a positive. 9 times 6 is 54. But just like when I take x times x and I get x squared, I times I is I squared. When I'm multiplying I times I need to raise it by 1 power. That's different than adding i's together or subtracting i's. When I add or subtract, I just keep the term the way I have it and combine like terms. Multiplying is a different procedure. If you look, I've really used the FOIL method. I've really distributed. First times first, outside times outside, inside times inside, last times last. Last step, combine like terms. 18 minus, I have negative 12 and minus 81 gives me a grand total of 93i plus 54, and I squared is negative 1 big. I is the only number that when I square it, I get a negative number. So I can replace I squared with negative 1. So really I have 18 minus 93i minus 54. Because I have 54 times negative 1. So now I can combine 18 and negative 54. I end up with negative 36 minus 93i.